Hello everyone, thanks for joining Jump Learning series. We'll see three things today in this video. How to create descriptive statistics using tabulate option, how to create descriptive statistics using distribution option in Jump, and how to check normality of a continuous variable. And we are looking at continuous probability distribution, checking whether a continuous variable follows normal distribution or not. So let's start with tabulate platform. I'm going to use the student data. You can use any of the data sets. So you can see there's a student ID, age, gender, height, weight, study hours, and CTC is the cost to company uh, stream, and as well as there's a feedback data. So the tabulate option is under analyze and tabulate. This platform helps you to interactively construct summary tables or pivot tables as well as descriptive statistics. So it's an easy and flexible way to present summary data in a tabular form. So tables are built from assigning data table columns as rows or columns in the tabulation and then assigning desired summary statistics. And this is how it looks like. So I just want to explore the descriptive statistics of all these variables height, weight, CTC. Just drag and drop it to the center. So by default, it gives me the sum of each of this variable. I'm not looking at sum. So instead of sum, I will take the mean here and drag and drop it here. So it automatically changes to average. So now let me make it a little bigger. I also need standard deviation. So if I drop it here, it gives me standard deviation as well. Okay, so assume that I now also need minimum and max. I'll put it here again. So for all the variables, I get min and max, uh, coefficient of variance, median. Let me select this mode, range. Okay, so I'll select range here. So based on where you drop, it starts giving options and outputs. Okay, so I'll make it like this. And then let me change the format. Okay, so use the same decimal format for everything and fixed decimal. And the number of decimals, let's say keep it 2. Okay, so now I get a table like this. I want to split this based on gender. I can just add gender to it so that I'll get a gender table here. Then I want based on streams. If I add it here, it gives me based on the stream. So I can also add rows as columns and columns as rows, kind of a transpose. So and then you need summary statistics here. Let me add a little more summary here. And there's few more options here. Show chart. I can also get a little more visualization, kind of a horizontal bar chart for each of the metrics which I want to show as part of tabulation. Uh, you can always save the script to data table, or else you can export the output in whatever format you want. So I'll start over. Let me do another tabulation here. Uh, okay, so instead of I'm using, there you go. So instead of doing horizontal way, I'm just doing vertical way. And I can also add a stream on top of it, or else you want both, you can add on top of it. Let's see, I want to split this by gender. Now that I get this. So use this tablet option to interactively construct summary statistics tables. And then you can export this using the selection button. Okay, copy. So you can paste wherever you want. Let me save this to data table as tabulation. Okay. Next, we are going to look at it. How can we create descriptive statistics using distribution platform? Under analyze, the first option is distribution. And just drag and drop all the variables, whichever you want descriptive statistics to Y columns, and then click OK. So now you will get distribution, frequency distribution of each of the variables depending on whether it's a continuous or else a categorical variables. You get some basic descriptive statistics. If you look at this age, even though age is a number, I've defined age as a ordinal variable so that it gives me only frequencies. However, you can change age as a continuous variable. And then frequencies, gender, it gives you frequencies. But you look at the height, weight, study hours, and all of this continuous variable, it gives you frequency histogram. Along with it gives you quantiles and summary statistics. So jump is a progressive tool. It doesn't give you all the output, but you can always explore. Whenever you see a red triangle like this, that means there's lot of options which you can explore further. For example, summary statistics, it's only shown mean, standard deviation, upper 95% and lower 95%. Click this summary statistics red triangle. There's an option customize summary statistics, which gives you option to choose various summary statistics measures, be it median, maximum, mode. Okay, you can choose whatever you want, and there is an option select all summary statistics and click OK. So you will get all the summary statistics related to this particular height variable. If you want to broadcast the same command to all the variables instead of doing individually this one, you can use the control button and say summary statistics and then customize, select all. If you see that instead of you doing for each of it, you can broadcast the same command. You just need to press control button along with when you press the summary statistics option. So this is how you can always export it and save it. Okay, so you can export the output or else you can save the output. Go to the top red triangle, save script to data table. This is summary statistics using distribution. Let me close this. I'm going to show you how to check normality of a continuous variable. As all of us know, normal distribution is a continuous probability distribution. I want to check whether height is normally distributed or not, or else the variable height represents a population which is normally distributed. Analyze distribution. I just want to drag and drop height here. Click OK. So now you're used to this. It gives you summary statistics. Let me minimize this quantiles. The first thing I'm going to check normal quantile plot. Okay, this will helps you to understand visually whether data is normally distributed or not. And if you see this, there's the confidence band which is dotted red color line, and there is a dark red color diagonal line. If the points are inside this dotted red color line and in and around that diagonal line, visually you can conclude that data is normally distributed. That's the first level of check. So once you check that, now it looks like all the data points are inside this dotted line curve, and then in and around this diagonal line, data is normally distributed. I'm going to fit a distribution here. As I mentioned, normal distribution is a continuous probability distribution. So I'll go to continuous fit under the red triangle, and then I can check for any distribution. I'll fit normal here. So now it fits a normal distribution and it gives you information related to fitted normal distribution. Under the red triangle of fitted normal distribution, look for goodness of fit. So there are two statistical tests which are used to confirm whether a variable is normal or not. Shapiro-Wilk and Anderson-Darling. Shapiro-Wilk is extensively used when number of records are less than 2000, and Anderson-Darling test is used when the number of records are more than 2000. Jump provides both the outputs. So if you look at the p-value here, if p-value is greater than 0.05, then variable can be concluded as normally distributed. I repeat again, if this p-value is greater than 0.05, the test is not significant because the null hypothesis is the data is from normal distribution. Okay, null hypothesis is data is from normal distribution. If p-value is greater than 0.05, you are going to accept uh, null hypothesis. That means data represents a population which is normally distributed, or from a layman's perspective, height is normally distributed because p-value is greater than 0.05. Let's check whether study hours is normally distributed or not. Okay, let me minimize this. Analyze distribution. Take the study hours, put it to Y columns. Okay, and then first thing which I'm going to look at is normal quantile plot. As you see, normal quantile plot looks like there are some data points which are close to the dotted line, the confidence curve. But I'm going to fit a normal distribution here, fit normal, and then I will check for goodness of it. Yeah. So this is for study hours, and let me keep both side by side. Okay, this is for height. Sorry, this is for height, and this is for study hours. Okay, so if you look at the uh, normal quantile plot, you can see that visually you can start observing that study hours may not be normally distributed, but you're going to validate that using goodness of it after fitting a normal distribution to the data. And if you see, the p-value is greater than 0.05, so that we can conclude height is normally distributed. And here the p-value is less than 0.05. If you notice that in jump, if the p-value is less than 0.05, because we have set the significance level as 5%, jump makes it little in a different color. So the p-value looks in red color or orange color, just giving you another indication the p-value is less than the significant value which we have set. So that means here p-value is less than 0.05. That means you can conclude the study hours is normally, it's not normally distributed. Sorry. So while height is normally distributed, study hours is not normal. So we learned three things today: how to create descriptive statistics using tabulate option, descriptive statistics using distribution, and then also checking for normality.